Let's imagine a system. It's a sort of semicircle where the radius here is, so this is a vertical semicircle, and we're going to put an object of mass m. We imagine that there's it's like a marble with a hole in it, and it can slide on this ring, or the half-circle ring, and the radius is, let's say, b, and let's find the equations of motion, right? Let's determine a Lagrangian. That looks very complicated, but if we write that this is the x direction and this is the y direction, all we need is to be able to find the x and y position and take the velocities. So we need to find x, and we need to find y, and then we can construct the Lagrangian and then follow the usual procedures. And the trick is to figure out what x and y are. So that takes a little bit of work, but if you use a parameter theta, then, so we have some angle theta, you can satisfy yourself by putting in values of theta and seeing that this parameterization will capture the different positions of the object. So we have b over 2 theta minus sine theta. So when theta is, well, first let's point out that we need our theta to be between 0 and 2 pi. So when theta is 0, this is 0 minus 0, and x is 0. So the object is here, and y needs to be b. So here we have b over 2 times 1 plus the cosine of theta. Let's see, theta is 0, this becomes 1, we get 2, and that gives us b. So we are at this y equals b when theta is 0 and x is equal to 0. And so now we can move along here. As you choose different values of theta, you can satisfy yourself that that's the parameterization. That's the hard part. But once we have that, it's all automatic. So we need to find the kinetic energy, right? Which is m over 2 times x dot squared plus y dot squared. And that is, well, let's first find x dot and y dot. So x dot is equal to, b is a constant, so we have b over 2 theta dot. The derivative of this is minus cosine theta, theta dot. And y dot, time derivative of y is, we get a minus b over 2. Right, the minus comes from this. We turn the cosine into a sine, and then we have a theta dot. And so our kinetic energy is m over 2 x dot squared plus y dot, oops, I already wrote that, whatever, which is m over 2. And now we have these terms, so we have b over 2 squared times, we have, let's pull the theta dot out here, we have a 1 minus cosine theta, theta dot, squared, plus a minus sine theta, theta dot, squared. And that's going to give us mb squared over 4 times 1 minus cosine theta, theta dot squared. And the potential energy is mg times the height, so it's mgy, and that is mgb over 2, 1 plus cosine theta, right, it's that. And so now we write the Lagrangian, which is k minus u, which is mb squared over 4 times 1 minus cosine theta, theta dot squared minus mgb over 2 times 1 plus cosine theta. And so now we want to evaluate d by dt of dl by d theta dot minus dl by d theta equals 0, right? That's the quantity we want to construct. That will give us the equations, the equation of motion. Right. There's only one parameter here that's changing, and that's theta. So what do we have? D by d, we have d by dt of dl by d theta dot. That gives us an mb squared over 2 times 1 minus cosine theta dot. We still have to take that other derivative, time derivative, and then we have minus dl by d theta, that is mb squared over 4 sine theta dot squared, plus mgb over 2 sine of theta, and that has to be equal to 0. So now we just evaluate this. Let's also pull out an mb squared over 2. So we take the derivative, we'll have this. Of that, we have 1 minus cosine theta. We have two derivatives in time, theta double dot, plus, now we have to take the derivative of the cosine, so we get a minus, so that becomes plus sine theta dot, and then we have theta dot, so theta dot squared, minus, now we're over here, sine theta dot squared over 2, right? So I'm just doing minus. I'm not doing anything with that. But I pulled out mb squared over 2, so there's a factor of 2 there. Minus 2 over b, because we pulled out a factor of b squared over 2. So 2 over b here, sine theta equals 0. And finally, 1 minus cosine theta times the acceleration term in theta, plus, we'll combine these two, sine theta dot squared over 2 minus 2g sine theta over b equals 0.